So here we are discussing test series 2, and we are at the linked data question. So we'll discuss question number 52 and we'll discuss question number 53 for that purpose. So the question belongs to the topic of transducers. So question number 52 goes as: in a vertically mounted venturimeter measuring water flow as shown in figure. The figure is given in your paper. The vertical distance between the tapping points 1 and 2 is 112 mm. The diameter of the meter is 1 at 1 is 100 mm and at 2 is 80 mm. If the pressure difference P1 minus P2 is 30.6 kN per meter square, then the velocity in the throat is. Assume the meter coefficient is 0.97. Now here there are certain things to be assumed and taken care of. So if you see the figure carefully, then the area of the tube at section 1 and area of the tube at section 2 is different. So for that we have to apply continuity equation. So first of all, continuity equation. So what continuity equation says is V1A1 is equals to V2A2. So this is the continuity equation. Because there are separate areas, so velocity will definitely differ. So if you take out the velocity V1, so it becomes V2A2 by A1, or A1 A2 is the dimensional parameter, so you can replace it by diameters also. So I am replacing it by d2 by d1 square. So now we have the V1 in terms of diameters, that is d2 and d1. So applying Bernoulli's equation, so now we have Bernoulli's equation. So now there are various assumptions to be made when you apply Bernoulli's equation. So that's the reason why I write in general that we are neglecting all the losses, because Bernoulli's equation can't be applied like that simply. So there are various assumptions to be made. So we say that we are neglecting all the losses. So what it says is V1 square by 2g plus P1 by W plus Z1 is equals to V2 square by 2g plus P2 by W plus Z2. So these are the three heads which has to be equal when you apply the Bernoulli's equation. So finally, if you see, if we convert this, if we solve this further, it's V1 square by 2g d2 by d1 to the power 4 plus P1 by W plus Z1 is equals to V2 square by 2g plus P2 by W plus Z2. So, and if you solve this further, it's P2 minus P1 upon W plus Z1 minus Z2, that is the potential difference, is equals to V2 square by 2g 1 minus d2 by d1 to the power 4. So it is a simplification of the equation. So your V2 square will be, that is your V2 square will be 2g P2 minus P1 by W plus Z1 minus Z2 whole divided by 1 minus d2 by d1 to the power 4. So if you solve it further you have 2 into 9.81 30600 divided by 9810 minus 0.112 divided by 1 minus 0.8, that is the ratio of the two diameters, by 4. So if you see, V2 is equals to 10 meter per second so 10 meter per second, and the actual wind velocity is given by, just multiply this factor by the discharge coefficient whatever they have given. So the actual mean velocity, it will be given by v bar. So multiply this thing by 0.97 into 10. So you have it to be some 9.7 meters per second. So this is the answer, and if you see, then option number A is correct.